Welcome all. In last lecture we have seen the serial input, serial output register with left shift mode, and I have given a homework for the right shift mode. Today we will see the other modes of the registers, that is the second one is serial input parallel output register, which is also called as a SIPO in short. In this, the data is entered serially and taken out in parallel. This is the serial input parallel output register for the 4 bits. First, the data is loaded bit by bit using this D input terminal of flip-flop 0. First data is loaded. At that time outputs are disabled as long as the loading is taking place. As soon as the loading is complete and all the flip-flops contains their data, then outputs are enabled so that all the data loaded is made available over the output lines simultaneously. Now here the number of clock cycles required to load a 4-bit word is 4. Hence the speed of operation of SIPO mode is same as that of the SISO mode. So in short, in serial input parallel output data, the data is entered into the register serially bit by bit, and the data is taken out parallelly, that is simultaneously at a time after the loading is taken place. Now next we will see the another type, that is parallel input serial output register, which is also called as a PISO. In this, data is loaded parallelly into the register. After that the data is taken out serially bit by bit. In this there are two modes in which the circuit can work, that is load mode and shift mode. This is the diagram of parallel input serial output register for 4 bits of data. These are the 4 flip-flops. The output of previous flip-flop is connected to the input of next one, that is this output is connected to the input of next flip-flop through a combinational circuit. The binary input word, that is B0, B1, B2, B3 applied through the same combinational circuit. These are the 3 combinational circuit through which the output of previous flip-flop is connected as an input to the next flip-flop, and also the data which is to be loaded parallelly is given as an input to each flip-flop through these combinational circuits. There are 2 modes, that is shift mode and load mode. We will see them one by one. Now first we will see the load mode. In this is the same circuit is taken over here. This is the shift oblique load terminal, which is made low for the purpose of operating it in the load mode. Means first we are going to load the data parallelly into this register. When shift oblique load bar line is low, then AND gates 2, 4 and 6 becomes active, and AND gates 1, 3 and 5 becomes inactive. Now we will see how this can happen like this. The AND gate passes the B1, B2, B3, that is AND gate 2, 4 and 6 passes this B1, B2 and B3 data to the D inputs of flip-flops, that is to D1, D2 and D3 of their corresponding flip-flops, and whereas this D0 is directly connected to the B0 line without any combinational circuit. On the first negative edge of the clock, the binary inputs B0, B1, B2, B3 will get loaded into the corresponding flip-flops. Thus, the parallel loading takes place. Now we will see with example how this load mode operates. Now suppose for example here I have taken the data as a 1011, which is to be loaded parallelly into this register. From this, the B0 line is connected directly to the D0, means the 1 is connected to the D0 input. After that, shift oblique load bar terminal is made low, by which, and this shift oblique load consists of this NOT gate, by which this line becomes 1. Here the values of this line written in white colored numbers. After that, and this line is of logic low, which is denoted by yellow colored. These are the logic 0 values of logic 0 line. Now we will see one by one what will happen. Now by making this line as a high, that is connected to AND gate 2, AND gate 4, after that AND gate 6, and a logic low line is connected to AND gate 1, AND gate 3 and AND gate 5. As the logic low line is connected to AND gate 1, 3, 5, the output of AND gate 1, 3, 5 will always remain as a 0, which is shown over here, irrespective of another input to them. After that, as a logic 1 line is connected to AND gate 2, 4 and 6, their output will be dependent on the binary data which we have given as a B1, B2, B3. So here the B1 line is having value 0, which is connected to this AND gate 2. Now AND gate 2 is having two inputs 1 and 0, so its output will be 0. This 0 and this 0 are connected to this OR gate, which will give final output as a 0. Means here this combinational circuit passes the value of B1, that is 0, to the D1 input of flip-flop 1. Similarly, this combinational circuit will pass the value of B2 line, that is 1, through this AND gate 4 to the D2 input of flip-flop 2, and in the same way this combinational circuit will pass the value of B3 line, that is 1, through this AND gate 6 to the D3 input of flip-flop 3, and the B0 line is connected directly to the D0 input of flip-flop 0. This is how the D inputs are connected through the combinational circuits to their respective flip-flops. So after connecting the respective input lines to the D lines of every flip-flop. On the low going edge of the clock, the binary inputs B0, B1, B2, B3 will get loaded into the corresponding flip-flops. Means this flip-flop will contain 1, this flip-flop will contain 0, this flip-flop will contain 1, and this flip-flop will contain 1. That is 1011, which we have considered as an example. That 4-bit word is loaded into these 4 flip-flops in the load mode. Now after the parallel loading of the data, means the data is loaded 1011, which we have considered as an example. After that, we are going to operate the circuit in the shift mode. For that, we have to make the shift oblique load line as a 1, that is, it should be at logic high level. By this, due to this NOT gate, this line is having a low level value, that is 0, and this line is having a high level value, that is 1. Now because of this arrangement, as this low line is connected to the AND gate 2, 4 and 6, the AND gate 2, 4, 6 becomes inactive now. Irrespective of other inputs to them, they will have a 0 output always. After that, a logic 1 line, that is this line, is connected as an input to the AND gate 1, 3 and 5, by which the AND gate 1, 3 and 5 becomes active now. As its one of input is 1, so output of AND gate 1, 3 and 5 will be dependent on the other input, that is this Q0 is the other input to the AND gate 1, this Q1 is the other input to the AND gate 3, and this Q2 is the other input to the AND gate 5. So this AND gate 1 will have a value of Q0 at its output. Similarly, AND gate 3 will have value of Q1 at its output, and similarly AND gate 5 will have a value of Q2 at its output. So this OR gate will have a Q0, this OR gate will have a Q1, and this OR gate will have a Q2 output, which are connected to the D1, D2 and D3 inputs of flip-flop 1, 2, 3 respectively. So this is how the previous output of flip-flop is connected as a D input of next flip-flop through this combinational circuit by making AND gate 1, 3 and 5 active. So once this connection is made, we can take the data serially out from this Q3 line, and this D0 line will be going to act as a serial input line. So the shifting of data from left to right bit by bit on the application of clock pulses becomes possible, in which the D0 acts as a data input terminal and this Q3 acts as a serial data output terminal. Thus the parallel in and serial out operation takes place. After that, we will see the next register, that is parallel input parallel output register, which is also called as a PIPO. This is the circuit diagram of parallel input parallel output register, which consists of 4 flip-flop. Therefore this is for 4-bit data, that is the 4-bit binary data B0, B1, B2, B3 is applied to the data input of D0 D1, D2 and D3 inputs of each flip-flop. As soon as the negative clock edge is applied, the input binary bits will be loaded into each flip-flop simultaneously at a time, and the loaded bits will appear simultaneously over the output lines. So this register will require only one clock pulse to load all the bits. Therefore, PIPO mode is fastest mode of operation. Now we will see the problems based on PIPO register. We have to study the given circuit and we have to calculate the time required to get output QA/QB as a 1-1. Means we have to find out the time to make QA/QB as a 1-1. Now the time required will be corresponding to the 1 clock cycle of this flip-flop, and we have and it is shown in this diagram that the clock frequency is of 1 megahertz. Means this one cycle will have a value of frequency as a 1 megahertz. Now we know the formula of time, which is nothing but 1 upon frequency. We are having the value of frequency as a 1 megahertz, means we can write it as a 1 into 10 raised to 6, which is nothing but 1 into 10 raised to minus 6 second, or we can read it as a 1 microsecond. So to make the QA/QB 1-1, the required time will be 1 microsecond. Now in a similar way we can find the time required for this circuit to make QA/QB as a 0-1. The problem is same, only the frequency of the clock is changed to 2 megahertz instead of 1 megahertz. Again we know the formula of time, that is 1 upon f. Again the value of frequency is 2 megahertz, means 2 into 10 raised to 6 hertz. We can write it as a 1 upon 2 into 10 raised to minus 6, means 0.5 microsecond. This is the time required for this circuit to get output as a 0-1. Thank you.